Hi, I'm going to explain about PWell fabrication process and NWell fabrication process. NMOS fabrication process is used to design only one transistor at a time. We know that NMOS fabrication process is used to design only one transistor. But here, if you take PWell fabrication process, so we can design the two transistors at a time by using single substrate. So I am taking here one substrate. So here I am taking N substrate, N substrate. N substrate is having electrons from the silicon material we have taken. So by using this, we can design the two transistors at a time. Here, source, gate, drain, source, gate, drain. How to design? I will explain. Here also we need to design source, gate, and drain terminal. So left side one transistor and right side one transistors. If you are design, then it is named as PWell fabrication process. If you take NMOS fabrication process, NMOS, only one transistor we are design using P substrate. We have designed that is NPN transistor, that is this is N, and we are deposited polysilicon material to design gate terminal. Of course oxidation is required. This is N and N. So only single transistor for NMOS fabrication process. But here using single substrate in PWell fabrication process, we can design the two transistors at a time. In 4 or 5 steps we can explain about PWell fabrication process. We can say this in the first step, they have taken N substrate. This is an N substrate having electrons. N substrate having electrons, and oxidation is common. Oxidation process means total surface is covered with the silicon dioxide layer. It gives the protection for the surface, and after that just diffuse the holes into N substrate. Here it is holes we are diffusing into N substrate by heating this material, of course using mask. So no need to mention about every total procedure. Here within 4 or 5 steps we can write. So here in the right side we are diffused holes into N substrate, that is named as PWell. This is the PWell. And in the next step to design left and right transistors. So left side where the transistor is required, just deposit the polysilicon material. And here also polysilicon material is deposited. In the red color mark we can see this. So this is a gate terminal. It is acted as a gate. Generally polysilicon material is used to design a gate terminal. Two gates are designed. Then we need to go for that is left side transistor. To design left side transistor, just diffuse the holes, because already it is an electrons material, N substrate. This is N substrate. There is only one option is there to design a transistor PNP. So this is an diffuse the holes into N substrate. So now in the left side third step we are design, that is left side transistor. So this is source, acted as a source, and this is acted as a gate, and this is acted as a drain terminal. Left side transistor completed. Using mask we can, of course we can diffuse. Next, coming to the fourth step, here left side transistor completed, then right side transistor. Using mask again we need to diffuse the electrons, because it is an PWell, already it is having holes. It is a P substrate, means it is having holes. There is one chance to design a transistor N NPN. So here diffuse by hitting this material, we are diffusing electrons into P substrate using mask, because the mask is used to unaffected the remaining area. So that's the reason they are using mask here. So here right side transistors also designed. This is the P-well process. At a time we are designed, that is left side one transistor, left side PNP transistor we have designed, PNP transistor we have designed, right side NPN transistor we have designed. So these two transistors are also used as a inverter circuit. How to design an inverter you can see using symbols, but here you can see this two gates are interconnected, gate 1 and gate 2, transistor 1 gate 1 and transistor 2 gate 1s are interconnected. Across that we are giving the input either 1 or 0, and across the source and drains interconnected we are taking the output. While giving 1 we should get 0, while giving 0 we should get 1. Anyhow, we will discuss about inverter operation. It is used as a CMOS inverter. So within 4 or 5 steps we can design an inverter, or else we can design an P-well process. Within a single step I will show you how to design an P-well process. We have taken N substrate here. Here you can see this. This is an N substrate. N substrate we have taken having electrons, and through this and diffuse the holes into N substrate, that is named as P-well. This is P-well. And to design left side and right side transistor, deposit the, of course oxidation is common, remaining process is common. I will tell you like simple steps. This is polysilicon material, polysilicon. Deposit the gate terminals. Deposit the gate terminals to design a transistor, and in the next step diffuse the holes, because it is an N substrate, mother substrate. Diffuse the holes into left side transistor. Now it is acted as a source gate drain terminal, source gate drain terminal. And right side we can see this, diffuse the electrons by using mask. Of course mask is compulsory. By using mask we can diffuse the electron, because only one option, because it is already P-well, there is a chance to design right side and PN transistor. So this is the NMOS NMOS diffusion. N diffusion symbol is, this is the P diffusion symbol. Like this we can design a P-well process. Using P-well we can design two transistors at a time. If you have any suggestions, please send to me, and thanks for watching. Please subscribe. Thank you.